Welcome to our monthly webinar entitled, But Wait, There's More! The SD-WAN Cost Model, presented by John Burke, who is Principal Research Analyst and CIO at Nemertes Research, and myself. This webinar consists of an interactive presentation and a moderated question and answer period. To submit a question, please use the control panel on GoToWebinar. Also, if you experience any technical difficulties, please contact webinars@nemertes.com. You can do that during the webinar, and hopefully we will get you back up and running. Upon conclusion, you will be presented with a short survey. Please answer the questions to provide feedback on this webinar and content for future webinars. We also ask if you would like to participate in our research. In exchange for your participation, if you're an IT executive, you will receive access to our research. A replay will soon be available for viewing on our website. And with that, let's go ahead and get started. John, I'm going to go ahead and turn it over to you. Take it away.
Thanks very much, Jonna. Always a pleasure to have another chance to stand up and talk about cool things. And this month, it's SD-WAN and the SD-WAN cost model, driven by our recent cloud and data center benchmark research, as well as some ongoing conversations with clients and others. So let's dive right in. We'll start by reviewing who we are, Nemertes, and informing folks who don't know about the wonderfulness. We'll then dive into what we mean by SD-WAN and the state of SD-WAN deployment in the enterprise. We'll look in on what we currently define as the SD-WAN cost model, inputs and outputs. We'll look at the cost impacts of some of the decisions people have to make as they deploy SD-WAN, and some caveats and qualifiers as folks decide what's going to be the right path for them going forward. We'll wrap it up with some recommendations and information about what's coming next in the world of Nemertes webinars. So first, about Nemertes, we are a research and strategic consulting firm analyzing the business impact of emerging technologies. So for the topics that we cover, ranging from things like today's topic, SD-WAN and cloud management platforms, all the way out to unified communications and collaboration tools and contact center technologies, we look at the real business value that deploying these technologies delivers to the company in question. And the main engine of our research, the main engine through which we generate this kind of information, is our unique benchmark of the enterprise with respect to its deployment and use of enterprise technologies. An ongoing process. We touch in several times a year on different topics, and it drives everything that we do. One of the things that we do, and where we typically debut some of our freshest, hottest research findings, is we put on the Nemertes Navigator 360 conference each year, coming up in July, the 25th through the 27th, at the beautiful and very pink Lowe's Don Cesar in St. Pete Beach, Florida, where we'll be discussing the digital enterprise transformation and how IT needs to be acting and changing itself in order to lead that transformation in a responsible and responsive way. And if you're interested in attending, please do contact us, and we'll get right back and discuss the possibilities. So let's talk about the WAN. The WAN. Everybody's always thinking about the WAN one way or another, and usually not in a favorable way if they're running their WAN in a very traditional fashion, because today's typical WAN in most locations in an enterprise's wide area network consists of one very expensive and very high-performing link into that branch in the form of an MPLS link, and one less high-performing but much less expensive backup connection to that branch in the form of an internet link. And excuse me, some branches don't have the internet backup and some branches don't have the MPLS primary, but in a typical branch you'll see both. The unfortunate thing about it is that although the internet link is there in case the MPLS link fails for some reason or becomes so poor performing or unreliable that the enterprise is better off switching away from it, that failover is typically not automatic, is typically anything but transparent, because it results in every session that's running across the link dying as paths are cut across from MPLS to internet. And of course, it means that the branch only ever gets the benefit of one of those connections at a time, either the MPLS primary or the internet backup, but not both. So you're paying for a lot of bandwidth you're not using, and when you take advantage of it, you're typically doing so at a significant cost in terms of administrative time to make the cutover and eventually the cut back, and in terms of disruptions to the enterprise's work as you first suffer through the degradation or disappearance of the MPLS link and then the bringing up of sessions on the internet link. So this is not ideal in many ways, and a market of opportunities for folks with very clever ideas about how to reframe our WAN connectivity in the branch, leading to first the hybrid WAN and more recently the SD-WAN. And the primary underlying assumption is that you should be able to make use of all the connectivity that you have. None of it should be sitting fallow if it doesn't have to. Instead, you should be using both your MPLS and your internet links into every branch or every location simultaneously. Maybe some kinds of traffic down one path and some kinds of traffic down the other, but all of it available to you, and preferably with much quicker and more transparent failover of traffic from one to the other in the event of problems on that particular connection. Both hybrid WAN and SD-WAN look to these kinds of benefits. SD-WAN looks to take the whole thing a step or six further by truly abstracting the WAN in both directions, looking down, abstracting the whole pool of available links, and it may not just be two, it may be 3 or 4 if folks have multiple internet links or they have an LTE backup to the internet, to the MPLS. Making all of that look like one pool of bandwidth, which can then be carved up and allocated to multiple virtual wide area networks overlaid on top of that existing pool of bandwidth so that you can match the topology of the virtual WAN to the needs of specific applications or services. Some applications may need a mesh topology so that every branch can talk directly to every other branch. And so you can create a virtual WAN that is a mesh and lay it over that pool of connectivity. Other applications may require, usually for compliance or security reasons, that all traffic route through a data center, maybe to go through a DLP appliance or some kind of auditing process. In that case, you can define a virtual WAN that is hub and spoke through your data centers. And then you can assign traffic into the virtual WAN that makes sense for them, for the specific needs of that service or that application. And more than abstracting the specific physical details of connectivity, more than opening up the possibility of creating multiple virtual WANs to overlay on that pool of connectivity, SD-WAN solutions as currently constructed aim to make managing the WAN a very different exercise in the future than it is for most people currently. The goal being that you get away from node by node management of specific routers on the WAN. So instead of managing the WAN by managing the router in location A and the router in location B and the router in location C individually, one instead configures the WAN and expects the management layer of the WAN to configure the devices as needed. One does this by defining policy in the center and expecting policy to be propagated out to each of the endpoints that make up the actual physical WAN. Policy to control not just which applications get which kind of virtual LAN assigned to them, but also issues of security. Where can traffic flow? Where will traffic not be allowed to flow? And more than that, even in most people's estimation, to help control performance. Which applications need to take top priority versus other applications? Which applications need to be guaranteed the lowest latency or the least variable latency among the pool of connectivity options available? Let the WAN management system figure out how to match the needs of the traffic to the pool of connectivity that's available and take that task out of the hands ongoing on a day-to-day basis of WAN engineers. They shouldn't have to poke in and tell this device, give that traffic priority over this traffic, or use this link for this kind of traffic. That should be something that's handled by automation and with minute by minute, second by second, millisecond by millisecond attention to how each of the links going into that particular location is performing at the moment. So SD-WAN, not just to have a higher level of abstraction, not just to have greater flexibility and less worry about the low-level details of connectivity in each location, but also to give you one place to define policy to control performance everywhere. That said, there are different ways that you can go about deploying SD-WAN. You can, and this is the most common model currently, deploy it over the top of your existing WAN infrastructure by laying a new appliance, for example, into each branch where you want the SD-WAN to touch. You can get that kind of overlay technology from a multitude of vendors currently. A few are listed here: CloudGenix, Mushroom, Silverpeak, Telari, VeloCloud, Versa, Viptela. There are more at either end of the alphabet there, and there are more all the time. So over the top is a broadly deployed option and one that we expect to continue to be very popular as these models develop. It's also important to note that although most of these solutions are currently deployed over the top, many of them give you the option of using them to replace the router, so that you wouldn't need to necessarily keep the router in place once you had put the Viptela or VeloCloud box in as well. Most of the folks we talk to don't jump right to router replacement. They start with overlay and think about their options. You can also, at the moment, and this is pursuant to that last point, deploy SD-WAN technology as services in the router. Cisco's IWAN offering is aimed at bundling together a set of services and intelligent activities that fulfill the function of SD-WAN and give you a centralized management plane for controlling how those policies roll out across your network. And lastly, of course, you can take this as a service, a managed service from a carrier. AT&T got out of the box early with this. Verizon, folks like Ariaka also in the space, where the service provider deploys a box to the branch and pushes network functions into that to achieve the ends of SD-WAN, giving you a management console through which you can centrally define policy that will be executed at all your locations. In our most recent benchmark of cloud data center and WAN subjects this past spring here, we found close to 20% of companies that we were talking to already deploying SD-WAN technology. That's pretty big slice of the pie, considering how recently these things really came to prominence. Another 9%, almost 10%, expect to have a solution in deployment before the end of this year. So we're going from essentially zero a few years ago, before the category really gelled, to a quarter of all companies in a very short span of time. And there's reasons for this, beyond flexibility, beyond simplification for network managers and designers, beyond agility in branch management. We get very high levels of interest in this because of the potential for very significant cost savings. WAN spending remains one of the largest single line items in an IT budget in the enterprise in the current day. And looking for ways to make significant reductions in that budget brings people to SD-WAN, brings people to the possibility of first making full use of the internet links they already have in branches, and later of potentially replacing MPLS links with internet links. So we built based on the research that we did this past spring with our benchmark and other research projects that we've undertaken with enterprises, we have built out a cost model to define the kinds of savings people should expect to see if they roll out an SD-WAN solution in their enterprise network. We're striving, of course, to keep it relatively simple on the input side. How many sites are there on your WAN? Do you want to go with a specific carrier's pricing for MPLS or internet services, or with our generic market take on what you should be able to find in the market currently? How many of your sites do you want to convert to the SD-WAN? And this is an important consideration for many companies because, for example, they may have 40, 50% of their sites in locations where there are no options for connectivity. They can only have the connections they currently have. They can't really do much with them. They may not want to put the SD-WAN solution in place in those locations because it will not be able to perform its primary function, which is improving connectivity performance, improving reliability by combining multiple links for you. There are other benefits that could come from deploying it for management, but without that primary motivation, they may say, well, I've only got 60% of the sites in my network where it makes any sense, so I'll do 60. Likewise, another benefit of deploying SD-WAN technologies is that it makes it easier for you as an organization to split some traffic that is headed for the wider internet out at the branch instead of sending it back through a data center somewhere, to send it directly to the internet, directly to Office 365, directly to Salesforce, directly to whoever. And in cases like that, a lot of organizations want to also have a full standalone firewall in that location. So if they want 30% or 40% of their branches to have direct internet access after the conversion, they may also want to have them put a full firewall in place in those locations. A lot of SD-WAN appliances incorporate significant firewall functionality. If that meets their needs, they might set this to 0, no matter how many direct internet access branches they plan. But if they're in the suspenders and belt mode, which most people are, at least through the first iteration, they'll probably layer on some firewalls. Likewise, WAN optimization is a major consideration in some networks. We've spoken with folks where 90, 95% of their branches have a WAN optimizer in place. And they get to decide, as they make this transition, whether they need to continue to have WAN optimizers in 90% of their locations, or if making the switch to SD-WAN will remove the need in most of those locations, and then they can decide how many they want to retain them in. And lastly, we can look at which model of, which architectural model of SD-WAN solution they want to deploy. Do they want to deploy a standard overlay, folks like Viptela VeloCloud, et cetera? Do they want to deploy in the network in the manner of AT&T or one of the carriers? Or do they want to deploy in the router via Cisco IWAN or similar? And then, of course, they have to define the kind of network they are. And we provide the ability to define, your top 4 site types. How much of your network is composed of the sites that have a 50 meg MPLS link and a 50 meg backup internet link? And after the conversion, do you want to keep MPLS? Do you want to keep the business internet? Or do you want to mix other kinds of connectivity into it? Do you want to drop the MPLS and double the business internet and throw in an LTE connection? Go ahead and define the before and the after for your top 4 site types. Try and get the majority of your network, and then press go and get some idea of the kinds of savings you should expect to see. Now, we talk about dropping MPLS, and a lot of people in their long-term plans think about dropping MPLS, but sometimes that is a very long-term plan in IT parlance, in that they're not thinking about it in the next 5 years. Only 10% of the folks we spoke to said, yeah, I'd like to drop MPLS, by 2019. An equivalent number said, give me 10 years. Most folks said, no, I'm not planning on dropping MPLS. What they are planning typically, though, is capping their use of MPLS, no longer pursuing bandwidth increases, riding the cost curve downward as their connectivity gets a little cheaper, contract renegotiation by contract renegotiation, and not expanding their use of it, potentially not adding it to any new sites. So they are looking at changing their use of MPLS, even if they're not looking at dropping it in the short term or even the medium or long term in internet years. And given that so many of the benefits, cost benefits of deploying SD-WAN derive from shifting, if not your network connectivity, at least your growth in network connectivity off of MPLS onto less expensive media, we thought it was a good idea to ask if folks are quantifying benefits from the SD-WAN deployment anyway. And 2/3 said yes, we're definitely not just seeing benefits in an intuitive sense, but quantifying them in terms of reduced number of WAN outages, reduced severity and length of WAN outages as well, and also a reduction in the number of trouble tickets their users send them about wide area connectivity. So even if they're not taking full advantage, even if they're not taking aggressive advantage of the ability to shift off of MPLS as their primary connectivity, they are seeing quantifiable and quantified benefits from deploying the technology. So with all that in mind, here's a fairly typical kind of a deployment scenario based on the conversations we're having with enterprises. And they're, as I say, being cautious. They're not saying, yeah, I'm going to throw away my MPLS links. They're instead saying, I'm going to keep MPLS in place as is in most of my locations, but for this type of site profile where I had a very low bandwidth MPLS link, and I've got the cheapest kind of internet link there to back it up, why don't I drop the MPLS for those and shift from one MPLS and one business internet link, business internet being symmetrical in both directions for speed and with some kind of SLA on it, and instead go to one business internet link and one commodity internet link, and we'll roll out with that. And with that in mind, and only that, so only dropping MPLS in 30% of sites, not replacing the routers, and with 150 locations on the WAN, this typical company would see a significant reduction in their spending on connectivity and in their WAN spending overall, because the spending on connectivity drops enough to cover the additional amortized capital costs of rolling out those appliances in all their locations. And of course, they drop another $10,000 worth of troubleshooting on their WAN as a result of that reduction in trouble tickets and outages. And so they wind up saving, $230,000 on their original $2.25 million a year expenditure on connectivity, on $2.6 million overall WAN spend. That's significant. That is a kind of number that gets people's attention, because it's not just that they're saving this money, they are at the same time improving availability, improving performance, and doubling the amount of bandwidth available in the locations, at least. Any place where they've got the same bandwidth in MPLS and internet, they're doubling. In the case of that 30% of sites where they're shifting from MPLS to all internet, they're more than doubling, because they've replaced a 5 meg MPLS link with a 10 meg internet link and a 10 meg business internet link to back it up. So more than doubling available capacity, seeing some speed improvements in some places, and also seeing cost reductions over current spending. That is a hugely attractive proposition, and as is obvious, the more of the MPLS connectivity that you limit or drop, the greater the reduction in that circuit cost, and moves the needle very rapidly on your savings. I mean, we see rates that would put you in the, 80 to 90% savings just on connectivity costs if you were, at this point in time, I would say foolhardy enough to throw all the MPLS out the door at the same time that you brought this in. Most people are respectfully cautious of throwing the baby out with the bathwater in this kind of a situation, though, and so they continue on with something close to the status quo, but make enough of a change to get solid cost reductions going forward. And it's not that they don't still have outages on their WAN links. And in fact, they may have more of them than in the past, but because this layer of intelligence is sitting in between their end users and those links and juggling traffic for them and transparently migrating traffic off failed links onto working links and then back again when the other links come back online, what we see is that their attitude towards those outages dramatically changes. It's no longer a drop everything, all hands on deck kind of an event when a branch's link fails because it's got the other link and nobody at the branch notices. So it becomes less of a disruption to IT's day-to-day work and gives them an opportunity to essentially wait and see if the problem is transitory and just goes away on its own before they start to address it with escalating interventions. And some of the solutions even provide a good enough data stream on link performance that the enterprises we're talking to turn that around as a stream of data to their MPLS provider to say, okay, the link was jittering up and down in latency for 6 hours in the middle of the day. Here are the stats, or it went down for 10 seconds here, it went down for 10 seconds there. Here are the stats, so that their service providers can do engineering troubleshooting on their end and improve service and prevent those outages or degradations of service going forward. So we ran a similar scenario through the eyes of somebody switching from their existing solution to an AT&T type carrier-provided solution, and we actually did plug in AT&T pricing for this one. So instead of, I'll draw attention to it, instead of going with commodity internet for their 30% of sites where they're dropping MPLS, they went to dual business internet links. That is a requirement of the AT&T service currently, goes currently along with currently pricing. So with that in mind, because they're delivering this service through a unified customer premises device that takes the place of multiple physical devices, and because we're able to make this one substitution in connectivity, we're again seeing some fairly dramatic savings over the current, classically provisioned WAN. And we're seeing even steeper reductions in problem resolution costs because some things that you would be troubleshooting on your own behalf, running your own overlay network, would be taken care of by your service provider in this scenario. So we see an even deeper reduction in problem resolution based both on it being a managed service and on it, again, transparently hiding issues with individual links connecting a branch into the wide area network. There are, as you can see, some significant provisos. This is assuming, of course, AT&T's pricing and services, therefore also assuming that you've got Ethernet connectivity for your service provider's service handoff, and that is actually a significant consideration. Again, taking that case I brought up earlier where 30–40% of the enterprise's sites are in locations with very limited connectivity options, and I was thinking of a specific enterprise that I've worked with, an F500 manufacturer, Most of those sites don't have any choice about what kind of connectivity they have. They have T1s and multiple T1s, and they don't get Ethernet handoffs for anything. So again, for those locations, this would not be an option, just as any box that wanted to replace the router but couldn't terminate a T1 wouldn't be an option. So in the long term, and long term is variously defined as people find their comfort level with this, as people see the technology prove itself out in practice or fail to, as the case may be, as their attitude towards just sitting pat with the MPLS they have evolves in the wake of those things. This is the kind of long-range scenario people describe to us, where only a very thin slice of their wide area network continues to have MPLS connectivity, and it's no longer the primary link for most kinds of traffic. It's dedicated to some very specific things and has capacity to meet the needs of those specific things, and of course fails over transparently to business or commodity internet whenever, if ever, there's a problem. But for the rest of their sites, they expect to go to some mix of business and commodity internet links, and to really lay in multiple links in every location, 2, 3, 4 maybe if they're going to go with LTE as another mode of access, and to really crank up the speeds as they make these transitions. And so in this longer term, they're looking at, again, making really huge increases in some things, like the speed they've got, up to a 10x increase in that, like the available bandwidth at each branch, maybe 30 times the bandwidth, and still getting that huge reduction in trouble tickets, still getting cost reductions, even with those major increases in their future network's capacity and speed. They're still looking at 10% reductions in over the cost of old connectivity, almost 10% of overall WAN costs. And that's assuming that they leave all the routers in place. If you start to not just replace MPLS, but replace routers with the SD-WAN appliances, you can see an enormous reduction in that amortized capital cost and drive the CapEx and therefore the overall cost way down, way down. So all of this about which I'm very excited, for which I'm very enthusiastic. I think lots of great things are going to happen for enterprises as a result of this technology rolling out, as a result of them finding the right level for it in their enterprises. It all comes with some caveats. The main one being, because it gives you the ability to slot in connectivity from any carrier in the area for a branch, it opens up the possibility that you will slot in connectivity from any carrier that's available in that branch, and you'll wind up with with scores of carrier relationships to manage. And that typically is not sustainable for IT. It becomes too many relationships to juggle. It becomes too many support organizations to work with. It becomes too many billing structures to work with, and accounts teams to work with, and bills to reconcile and check for errors and deal with discrepancies on. So we see folks who are very careful about this, selecting a very small pool of alternative carriers for the other kinds of access they're going to provide in their branches, looking for, regional best options, looking for multinational alternatives that are available for most of or all of their locations, or looking for some kind of aggregator who will be their single point of interface with what turns out in practice to be dozens or hundreds of carriers across the nation or around the world. We expect we expect carrier aggregators to be very popular for the next few years as this technology rolls out fairly quickly. And of course, that caveat I mentioned just a moment ago about having Ethernet as your service termination point from your service provider. Most of these appliances that you can drop in place of a router, putting the SD-WAN in place of the router, require Ethernet as the input. And if you can't get it, then you need something that will terminate the T1s or the T3s that you have providing your service interface. And in most cases, that's going to wind up being the router that's already in place. So if you don't have Ethernet coming in, you'll wind up not being able to do a straightforward router replacement right away, until you do have it coming in, basically. And keeping a full router on as a media converter, not optimal from a cost or management perspective. So something to keep in mind as you look at the possibilities for your company. And you should look at the possibilities for your company. You should be exploring the SD-WAN options that are out there, not just from the perspective of saving money and holding all other things equal and swapping cheap bandwidth for expensive bandwidth. You can save a whale load of money right up front, but that's not often the prudent course of action. So you should be looking for savings, definitely, no matter what scenario you proceed with. But you should also be looking at the improvements that you're going to get in performance, the improvements that you're going to get in availability and in service continuity to your users. Look at the broad array of options that are out there. The long list of vendors is getting longer still all the time. Currently, we're still in the growth phase of the market list. We're not yet deeply into the acquisition and contraction phase that will shorten it again. Narrow that to a short list that accompanies multiple architectural strategies, overlay or router integrated, managed, or do it yourself, and try more than one option. Most of these technologies make it possible to try without committing to converting your whole WAN and to see benefits without committing to converting your whole WAN. And shape your strategy based on not just your goals and requirements for the WAN, for uptime, for performance, and keeping in mind the things that you're planning to do in your service environment, your intentions with respect to rolling out UC applications or taking advantage of more cloud-based solutions. You also need to keep in mind the realities of your WAN, how connectivity actually reaches your locations currently, what's possible for your locations currently. And then looking at the cost of those things and the cost of managing connectivity, that profusion of carrier relationships that's possible, and the cost of managing the SD-WAN solution itself. It should be easier to manage than doing things the old-fashioned way, and if it's not, then you're making a mistake and you need to try another option. And of course, the overall cost of managing your WAN, what your staff see as the end result of deploying this technology should be not just an improvement in service, but a reduction in the amount of effort they have to put in to get that improvement in service. Anyone who's interested in more information on this and on our research and the cost model specifically, please contact Nemertes. If you're a client, drop a note to client-services@nemertes.com or call us at 1-888-241-2685. If you're not a client, please contact Nemertes Sales, sales@nemertes.com, or again, 1-888-241-2685.
Thanks, John. And before we jump into the next webinar, maybe we can take some quick Q&As. People have this on the screen. I know because there's a number of great questions here for you. I would like to start with a number of people have asked, are you going to have the recording posted? So short answer to that, yes. Very likely it could be any time between now and but we will notify everyone that participated that it's up, so you can catch it if you missed it or show it to your friends, all that good stuff. And John, we do have a bunch of questions on the architecture, so I wanted to make sure we could get a few of those answered before we kind of wrap up and send everybody off into our next webinar. I'm going to go a little bit in inverse order. Somebody asks, you had 4G listed, but you didn't really talk about it. Can you talk about that a bit? Like, where does this fit into everything?
Sure. It's an increasingly viable option for, if not primary, then backup connectivity or secondary connectivity, especially in metropolitan areas. It's often an option to plug a card into an SD-WAN appliance or a router to get 4G connectivity into the box as another path for sending traffic. And so we include it. It's an option that with the cost model you can build in to your before and after scenarios. People,
Great.
Why would people want it? Obviously, it's of great interest to folks whose wired connectivity is in a sort of a high-risk mode. Like if it all goes through one conduit out to a major service conduit a block away. One backhoe cuts every kind of connectivity they've got in that case. So for them, falling back to 4G is a lifeline.
Yeah, and I think also the ability to just do kind of, especially if you're in global expansion mode and you want to drop in a branch in a box and get some connectivity up and running, it's a great way to do that.
Absolutely.
The industry's been waiting for a long, long time. So, I have another question for you, actually a number of questions on architecture. Someone else writes in and says, hey, how exactly do you get SD-WAN without replacing the current router? And maybe you can speak to that a little bit.
Basically, it sends traffic through the router, and in the same way that WAN optimizers can work from behind the router, SD-WAN appliances can work from behind the router. It shifts a lot of the work that the router might have been doing onto the SD-WAN appliance is all.
And
you're tunneling through it, basically.
Okay, and just to clarify on that and expand a little bit further, if somebody is going with a Cisco IWAN approach, that's usually an upgrade to the existing router, or is that a swap out?
That depends on the age of the router. If you're in the second generation ISR technologies, and I'm drawing a blank on the exact number where the divider came, your router should be able to run the IWAN software. If you've got an older generation, and taking that manufacturer I was working with earlier in the year as an example, 60% of the routers were pre-generation 2. Those would have to be replaced. Got it.
And you mentioned, by the way, WAN optimizers. Somebody actually had a question in here. Why would you remove the WAN optimizer? Does SD-WAN replace that? Are there people who've seen as much improvement with SD-WAN as they have with WAN optimizers?
People have WAN optimizers in place to do multiple things, and some of them SD-WAN does, and some of them SD-WAN doesn't. WAN optimizers prioritize and traffic shape, so they decide which applications get what kind of access to the available pool of connectivity, and SD-WAN does that too. So if that's your main use for the WAN optimizers, then SD-WAN replaces it for you. You also look at it as an acceleration technology. So it might know tricks for accelerating specific kinds of traffic, cutting down on the number of round trips for old style file sharing, that kind of thing. A lot of folks are finding that their need for that specific kind of acceleration is fading as their pool of applications shifts over time. So SD-WAN taking care of prioritizing might let you let go of that as well. It's essentially moot. And then third is compression. And SD-WAN solutions typically don't do anything about compression, but because they generally are dropped in a way that vastly increases the available bandwidth in a location, they can remove the need for compression and replace it with capacity, essentially. Capacity combined with traffic shaping to prevent massive file transfers from stepping on higher performance requiring network apps. So in that case, SD-WAN doesn't do the same thing, but it can remove the need for that operation. And so what you're left with is kind of a core residual set of businesses and applications that have very specific file compression needs that extra bandwidth doesn't really help. and so they have no choice but to keep WAN optimizers in place as WAN optimizers.
Excellent. So hopefully that answers the question in depth for the person who asked. Here's another one, and I think this is just one of your favorite questions, John. I know you anticipate a reduction in, or you actually predict or find a reduction in WAN troubleshooting ticket and outages, but do you think there's still a need for monitoring for troubleshooting and planning purposes? I think I know what you're going to say, but go ahead, take it away, John.
Well, yeah, absolutely. Yeah, you can't stop watching just because it behaves better. And in fact, you should look for your SD-WAN solution, if you roll one out, to provide you with better monitoring and visibility into your WAN than you've ever had before. You should be able to see more than you used to and get better information about when applications are having problems or when links are having problems.
Absolutely, and I knew you were going to say that because for the folks on the call, John is Mr. Operations and loves to think about these things. So yes, absolutely. There's a question that someone has not asked, but I wish they would, which is, hi, I'm an enterprise organization, and with this cost model, is it possible for me to do something like plug in my cost data and, solution of choice, or perhaps do some, scenario building and decide what should be my solution of choice? Is this an interactive cost model that I can use as a decision assist?
The answer is yes. Yes, of course. It's fully interactive, and it's built with the idea that you'll do before and after modeling. That's why it's set up with the inputs it's set up with. So you can play around with the expected mix of connectivity on the far end, see what kinds of changes you should be able to expect in cost and structure of cost as a result, and to substitute in, carrier versus overlay versus in the router as your model for deployment. We actually do provide a mechanism by which people can supply their own MPLS and internet cost structures. So what are they paying for this size link into that location and that size link into the other location? And, we'll construct a pricing table based on that for your before and after as well, supplementing with generic market-based pricing. One of the nice things is if you plug your numbers in and using your numbers is significantly more expensive than using the generic numbers we're providing, it's a signal that you probably should be renegotiating your internet and MPLS contracts for lower prices.
Which is always a good thing to know. Yes, being able to benchmark your rates is always a wonderful service. Okay, we have a number of, well, actually we don't have a number. We have a couple extra questions, but I'm sort of keeping an eye on the clock. I'll make sure we'll reach out and get those questions answered. And John, I will sort of turn it back over to you to introduce the next webinar in case folks have not gotten it down from the slide already, and just go ahead and talk a little bit about what's coming and how they can get get access to it, and we'll wrap it up.
Absolutely. So coming up next in August on the 9th at the same time, our esteemed colleague, Erwin Lazar, will be digging into team chat applications. And will team chat finally kill email once and for all? What you need to know about GLIP, HipChat, Slack, Spark, and more. And this is a pretty exciting topic for us because we became very enthusiastic converts to team chat applications in this past year, and are very enthusiastic about the possibilities for other organizations as well. So if you're interested, again, that is in August, on August 9th, also a Tuesday, also at 1 p.m. Eastern Daylight Time. I will not read off the registration link number, but you can see it on the slide. You'll be able to see it in the replay. And, of course, if you want to register, you can also hit www.nemertes.com, and on the front page, you'll find a blurb for the webinar and a link as well for registering there.
Okay, great. And again, we will be reaching out to folks and following up, letting you know when the webinar will be posted. If you have any additional questions, please don't hesitate to contact us. You can also reach out to John Burke directly, as you can see. And thanks, everybody, for participating, and thank you, John, for doing such a fabulous job, as always. Thank you.
And thank you, Jonna.